Hidden beneath violent straits, carved through snow-covered mountains, and rising above waters that never stop moving, Japan has built structures that almost seem impossible to exist on Earth. These are not merely bridges, tunnels, or high-speed railways. They are silent battles between human ambition and forces far greater than us. Ocean pressure, earthquakes, blizzards, fractured rock, and currents powerful enough to punish a single mistake. From the Seikan Tunnel, buried deep beneath the sea, to steel bridges stretching across the sky, each project carries a secret story of risk, loss, precision, and almost unbelievable determination. This journey is not ordinary travel. It is a passage into the hidden heart of Japan's greatest engineering wonders, where concrete, steel, and human courage challenge the limits of nature itself. Dominating the frigid harbor of Muroran in Hokkaido, the Hakucho Bridge stands as the largest suspension bridge in eastern Japan, soaring elegantly over a treacherous maritime environment. Completed in June 1998, after a grueling construction period that began in 1985, this bridge spans a total of 4,527 feet, with a massive central span of 2,362 feet. Erecting a gigantic steel structure in an extreme northern climate forced engineers to pioneer cutting-edge techniques, utilizing model testing to predict heavy snowfall loads, and implementing the world's first continuous underground wall for its deep foundations. The main towers were meticulously assembled by stacking 15 separate sections, achieving an unbelievable precision with only a 13mm misalignment. Designed to resemble the graceful wings of a swan, the white cables and towers provide a stark, stunning contrast to the dark, freezing waters of the bay. The Hakucho Bridge is an unyielding monument to atmospheric endurance, proving that precise engineering can create a soaring architectural masterpiece even in the most punishing, snowbound territories of the north. Pushing the technological frontier northward into a landscape defined by extreme winter weather, the Tohoku Shinkansen is a high-speed artery built to withstand freezing elements. Gradually extended until it reached Shin-Aomori in 2010, this monumental route faces environmental challenges that would cripple ordinary rail systems, including overnight snowfalls that frequently exceed 3.3 feet. To ensure absolute punctuality during blizzards, this route forced engineers to employ a deeply elevated concrete slab trackbed that physically raises the trains above the snowdrifts, while specialized track sprinklers continuously melt accumulating ice. Because the line traverses the Pacific coastal region, one of the most seismically active zones on the planet, every pillar and viaduct is reinforced with heavy seismic resistance. Traveling this route offers a stark contrast. Passengers glide smoothly through a warm, quiet cabin, while a violent, frozen wasteland rushes past the windows at 199 miles per hour. The Tohoku Shinkansen is a triumph of atmospheric endurance. Rising 528 feet against the steep valleys of Gifu Prefecture, the Tokuyama Dam stands as a gargantuan rock-filled fortress that reshaped the entire geography of the Ibi River. Completed in 2008, this monumental structure holds the title for the largest total reservoir capacity in Japan, designed to contain a staggering 660 million cubic meters of water, a volume twice the size of Lake Hamana. The construction of such a colossal barrier forced engineers to reinvent material logistics, utilizing 11 massive 90-ton dump trucks to move millions of cubic meters of recycled sediment and rock. At its peak, the project achieved the highest annual embankment placement volume in the nation, pushing heavy machinery and human endurance to their absolute limits. The resulting artificial lake stretches across an area equivalent to Lake Suwa, completely submerging former villages beneath its deep, emerald waters. Bridging this immense expanse is the Tokunoyama Bridge, featuring one of the world's longest center spans for its class, which seemingly floats above the flooded valley. For the observer, the Tokuyama Dam is a masterpiece of extreme geometry and sheer weight, a silent, unyielding wall where rock and gravity conspired to tame the unpredictable, destructive forces of the Japanese river system. Carving through the formidable Tanigawa mountain range, the Kan-Etsu Tunnel broke an absolute geographic barrier by linking the snowy landscapes of Niigata with the Kanto Plain. Stretching approximately 6.8 miles beneath the peaks, this visionary endeavor was initiated to conquer the isolating winter conditions that historically severed the region. The excavation forced engineers and laborers to battle highly pressurized groundwater and massive fault lines, employing advanced rock drilling methods that pushed human endurance to its absolute limits. Reaching its staggering length, this subterranean passage revolutionized the nation's logistics by allowing continuous, all-weather vehicular transit, completely bypassing the perilous, snow-choked surface passes. The thick concrete walls bear the immense, unseen pressure of the mountain above, while giant underground ventilation shafts supply life-sustaining air to the depths. Even today, as millions of vehicles traverse its length annually, the Kan-Etsu Tunnel remains a silent, concrete vault where raw engineering meets the crushing silence of the Earth's depths. It stands as a historical monument to the pioneers of subterranean construction, a grueling endeavor that forever altered the landscape of Japanese highway transportation. Spanning the sprawling industrial harbor of Nagoya, the Meiko Triton is an awe-inspiring triad of cable-stayed bridges that physically dominates the skyline of the Ise-Wangen Expressway. Completed in March 1998, after 8 rigorous years of construction, this colossal maritime corridor connects the Tokai and Tobishima interchanges over one of the busiest shipping lanes in the world. Consisting of the east, central, and west bridges, this infrastructure forced engineers to elevate the highway high above the ocean to allow enormous cargo freighters to navigate unobstructed beneath the massive concrete decks. The sheer scale of the project is visually matched by its striking aesthetics, as the 3 towering main pylons are distinctly painted in vivid blue, white, and red to reflect the nautical colors of the sky, sea, and sunset. The Meiko Triton is not just a triumph of structural endurance. It is a vibrant, mechanical crown stretched across the dark ocean, proudly symbolizing the industrial heartbeat of central Japan. Slicing directly through the bustling waters of Tokyo Bay, the Tokyo Bay Aqua-Line represents an audacious fusion of subterranean and aerial engineering. This 9.4 miles hybrid structure seamlessly links Kawasaki with Kisarazu, drastically reducing travel times across the congested bay. The journey begins with a massive underwater tunnel, plunging deep beneath the shipping lanes, forcing engineers to use colossal shield machines to conquer the soft, unpredictable seabed. Midway across the bay, vehicles suddenly emerge into the light at Umi-Hotaru, a colossal artificial island functioning as a rest stop suspended between sea and sky. From there, the route transforms into a sprawling bridge that glides gracefully over the waves, offering drivers an unobstructed, cinematic view of the capital's skyline. The Aqua-Line stands as a masterful display of overcoming marine obstacles, a vital economic artery that literally paves a path over and under the crushing weight of the ocean, defying the traditional limits of coastal infrastructure. Suspended elegantly above one of Japan's most volatile waterways, the Akashi-Kaikyo Bridge presents a stunning visual counterpoint to the powerful ocean currents swirling below. Designed as a massive stiffened truss suspension bridge, this engineering marvel spans a total length of 1,131 feet, connecting the city of Kobe to Awaji Island. To achieve a mind-boggling central span of 6,532 feet, the bridge forced engineers to overcome unprecedented challenges, battling extreme marine winds, deep seafloor excavation, and the constant threat of devastating earthquakes. Supported by monumental steel towers rising from the depths, the truss structure was specifically engineered with extreme rigidity to absorb the violent typhoons that frequently batter the region. Its completion completely revolutionized regional transit, transforming a perilous and unpredictable ferry crossing into an effortless, high-altitude sprint over the sea. As daylight fades, the colossal cables and towers are illuminated, casting a striking reflection across the dark, turbulent waters of the strait. The Akashi-Kaikyo Bridge does not merely span a physical distance. It acts as a majestic steel crown over the ocean, capturing the delicate balance between structural monumentality and the relentless, untamed forces of nature. Stretching across the mountainous spine of Honshu from Tokyo to Niigata, the Joetsu Shinkansen is an unparalleled feat of engineering, designed to conquer Japan's legendary snow country. Along this 167.5-mile route, winter weather is not a mere inconvenience. It is a punishing force of nature, where overnight snowfalls routinely exceed 3.3 feet, threatening to bury any conventional infrastructure. To maintain high-speed operations without interruption, this environment forced engineers to implement a massive snow-melting system, utilizing thousands of track sprinklers that draw warm underground water to instantly dissolve the heavy accumulation. A significant portion of the route dives underground to bypass the treacherous alpine peaks, relying on monumental tunnels to shield the tracks from avalanches and freezing winds. This intensive infrastructure transformed an impassable winter journey into a swift, reliable commute, deeply integrating the Sea of Japan coastline into the rapid pulse of the capital. It remains a stark monument to humanity's refusal to yield, turning the harshest climatic barriers into a theater of high-speed triumph. Before the era of high-speed rail and modern bridges, the Kanmon Railway Tunnel broke an absolute geographic barrier by becoming the first undersea tunnel in the world. Constructed beneath the Kanmon Strait to connect Honshu and Kyushu, this visionary endeavor was launched in 1936 and opened for freight in July 1942, amidst the global turmoil of the Second World War. The excavation forced engineers and laborers to battle highly pressurized groundwater and unstable rock layers, employing pneumatic caissons and early shield tunneling methods that pushed human endurance to its absolute limits. Reaching a total length of over 2.2 miles, this subterranean passage revolutionized the Even today, As bullet trains and expressways soar overhead or run in parallel tunnels, the original Kanmon Railway Tunnel continues to serve as a vital, silent artery. It stands as a historical monument to the pioneers of underwater engineering, a raw and grueling endeavor that forever altered the landscape of Japanese transportation and laid the groundwork for future oceanic crossings. Beneath the treacherous waters of the Tsugaru Strait, the Seikan Tunnel stands as a monumental triumph of human engineering, born from the tragic sinking of the Toyomaru ferry. This 33.46-mile undersea railway tunnel was conceptualized to forge a safe, permanent link between the main islands of Honshu and Hokkaido. Construction began in September 1971, demanding 17 years of relentless struggle against immense water pressure and unpredictable seabed geology. This tunnel forced engineers to excavate 787 feet below sea level, constantly facing the lethal threat of sudden seawater inundation. Inaugurated in March 1988, it remains one of the longest and deepest operational rail tunnels on Earth. The darkness of the subterranean space contrasts sharply with the vital connectivity it provides, transforming a perilous sea crossing plagued by typhoons into a seamless journey. The Seikan Tunnel is not merely a transportation artery. It is a silent, submarine fortress, where steel and concrete conquer the crushing weight of the ocean. It stands as a lasting testament to Japan's unyielding determination to overcome its heavily fractured geography through sheer mechanical persistence. Expanding the mastery over the Kanmon Strait, the Kanmon Roadway Tunnel emerged as an architectural rarity that separated vehicular and pedestrian traffic within a single subterranean structure. Initiated in 1939, but heavily delayed by wartime shortages, this tunnel required an agonizing 21 years and 4.66 million workers before finally opening in March 1958. The thick concrete walls bear the immense, unseen pressure of the sea above, while massive ventilation shafts supply life-sustaining air to the depths. The Kanmon Roadway Tunnel remains a masterpiece of utilitarian design, transforming a formidable marine obstacle into an enduring corridor of human resilience and seamless connectivity. Walking the narrow pathway beneath the ocean floor offers an unforgettable experience where travelers can literally cross the prefectural border between Yamaguchi and Fukuoka on foot across a 2.15-mile stretch. This monumental infrastructure not only bypassed the perilous surface currents, but also facilitated the post-war economic resurgence by ensuring an uninterrupted flow of goods and people. Suspended elegantly above one of Japan's most historically significant and heavily trafficked waterways, the Kanmon Bridge presents a stunning visual counterpoint to the hidden tunnels below. Completed in 1973, after 5 years of intense construction, this 3,504-foot suspension bridge was engineered to relieve the crippling congestion of the underwater arteries, while allowing the dense fleet of cargo ships to navigate the strait unobstructed. Supported by massive steel towers, the truss structure forced engineers to design with extreme rigidity to withstand the violent typhoons and harsh marine winds that frequently batter the region. As daylight fades, the bridge is illuminated, casting a striking reflection across the dark, swirling waters where ancient naval battles once decided the fate of empires. Running like a steel spine through the rugged terrain of western Japan, the Sanyo Shinkansen is a masterclass in linear engineering against a fractured landscape. Opened fully in 1975, to connect Osaka and Fukuoka, this 344-mile high-speed corridor was forced to carve its path directly through formidable mountain ranges, resulting in a route where nearly half of the entire length consists of deep tunnels. To dramatically reduce life cycle costs and eliminate the constant maintenance required by traditional crushed stone ballasts, this railway forced engineers to deploy continuous concrete slab tracks across the entire line, a revolutionary technique that defined the future of high-speed rail. The structural demands were immense. Viaducts and tunnel portals had to be meticulously engineered to mitigate the violent micro-pressure waves generated when trains punch through the darkness at nearly 186 miles per hour. This massive undertaking fundamentally shifted the economic flow of the nation, turning a grueling coastal journey into an effortless sprint. The Sanyo Shinkansen is a mechanical ribbon of extreme precision, a relentless testament to human ambition that pierces straight through solid rock rather than bending to the will of the mountains. Pushing the high-speed rail frontier along the rugged coast of the Sea of Japan, the Hokuriku Shinkansen extension to Tsuruga represents a triumph over complex coastal geology. Opening in March 2024, this 77.6-mile corridor was forced to carve its path directly through formidable mountain ranges, resulting in a route where nearly a third of the entire length consists of deep tunnels. Excavating the massive 12.3-mile Shin-Hokuriku Tunnel required engineers to overcome unstable ground and heavy snowfall conditions, laying continuous concrete slab tracks to ensure absolute precision. To conquer the deeply fractured terrain, the project relies heavily on monumental viaducts, which make up over 52% of the track, lifting the bullet trains above the coastal settlements and agricultural plains. This engineering masterpiece fundamentally shifted the economic flow of the Hokuriku region, turning a grueling coastal journey into an effortless, high-speed sprint. The Hokuriku Shinkansen is a mechanical ribbon of extreme precision, a relentless testament to human ambition that pierces straight through solid rock rather than bending to the will of the mountains.